Lesson 7. Distance along small circles. Since the parallel of latitude is a small circle, distance between any 2 points on it is given as distance d equal to theta over 360 degrees times 2 pi arrow, where arrow is the radius of parallel of latitude given as the product of the radius of the earth and cosine of the angle of latitude. You come here and replace radius of parallel of latitude by this formula, and you have the distance to be in this form. So for any small circle, the distance between any 2 points on it is obtained using this formula, where theta is the angle for longitude, alpha angle for latitude, capital arrow radius of the earth. Examples number 17. Find the distance correct to 3SF along parallel of latitude between the following points. Take pi equal to 3.142 and radius of the earth equal to 6,400 kilometers. You have A part of the question, points arrow and T. B part of the question, points P and Q. Solution: A part of the question, distance arrow T. It is along parallel of latitude, and you can obtain it using this formula. Theta, angle of longitude, is the subtraction of the two given longitudes because they are on the same side of the prime meridian. So theta is equal to 44 degrees. Alpha, angle of latitude, is equal to 18 degrees. To get distance ROT, you come here and you replace all the parameters with what they stand for. You have it in this form. When you simplify, you have this result. To 3SF, distance ROT is approximately equal to 4,670 kilometers. B part of the question, distance PQ is also along parallel of latitude, obtained using this formula. Theta, angle for longitude, is through addition because the given longitudes are on different sides of the prime meridian. When you add, you have 30 degrees. Alpha, angle of latitude, is equal to 40 degrees. To get distance PQ, you come here and replace all the parameters with what they stand for. When you simplify, you have these results. To 3SF, distance PQ is approximately equal to 2,570 kilometers. Example 18. Two towns K and Q are on the same parallel of latitude 46 degrees north. The longitude of town K is 130 degrees west, and that of town Q is 103 degrees west. A third town P, also on latitude 46 degrees north, is on longitude 23 degrees east. Calculate, remember figure 1, the distance between K and Q, correct to the nearest 100 kilometers. Remember figure 2, the distance between Q and P as measured along the parallel of latitude to the nearest 10 kilometers. Take pi equal to 3.142 and radius of the earth as 6,400 kilometers. You simply mash the various points together. K is latitude 46 degrees north, longitude 130 degrees west. In this form, you mash other points together. If you have listened to lessons 3 and 2, this diagram represents the above information. You have to visit those lessons and listen to them in order to understand what happens here. Roman figure 1, distance KQ is given by this formula. The 2 points K and Q are on the same side of the prime meridian, so their angular difference is through subtraction, and you have 27 degrees. Alpha, angle of latitude, is equal to 46 degrees. You come here and replace the various parameters with what they stand for. You have it in this form. When you simplify, you have these results. The question says to the nearest 100 kilometers, starting from the point to the left, 5 is under unit, 9 is under tens, 0 is under 100. You consider the next digit 9, you round 8 up to 1 and you add it to 0, it becomes 1. So you have 2100, that is 2,100 kilometers. Roman figure 2, distance PQ is also along a parallel of latitude obtained using this formula. PQ are on different sides of the prime meridian, and as such their angular difference is through addition. You have 126 degrees. Alpha, angle of latitude, is equal to 46 degrees. You come here and you replace all the parameters with what they stand for in this form. When you simplify, you have this result. To the nearest 10 kilometers, you are to consider 7, the second 7 from left. The next number 8, you round 8 up to 1, you add it to 7, it becomes 8. So you have 9,000 780 kilometers. Example 19. A town S is on longitude 20 degrees west and latitude 30 degrees south. A second town Y is on the same latitude as town S and on longitude 20 degrees east. Find a part of the question. The circumference of the circle of latitude 30 degrees south correct to the nearest 100 kilometers. B. The distance between S and Y measured along the parallel of latitude. Solution. Circumference of the circle of latitude 30 degrees south is equal to 2 pi r. In this context, r is the radius of latitude that is equal to the product of the radius of the earth and cosine of the angle of latitude given in this form. Alpha is equal to 30 degrees, the angle of latitude. Therefore, circumference is equal to 2 times pi times radius of the earth times cos 30 degrees, and that is equal to this. To the nearest 100 kilometers, you have the circumference to be 34,800 kilometers. Distance SY is measured along the parallel of latitude. It is a small circle obtained using this formula. S and Y are on different sides of the meridian, so their angular difference is through addition. You have it to be 40 degrees. Alpha remains 30 degrees. You come here and you replace all the parameters with what they stand for. You have it in this form. When you simplify, you have this result. To the nearest whole number, you have the distance between S and Y to be approximately equal to 3,870 kilometers. Example 20. S is a point on latitude 28.6 degrees north and longitude 105.7 degrees west. Y is on the same latitude as S but lies on longitude 34.3 degrees east. Calculate the distance S and Y along latitude 28.6 degrees north. Assume that the Earth is a sphere of radius 6,370 kilometers. Solution. Distance SY along latitude 28.6 degrees north is a long small circle. If this point were to be 0, we would take it as the equator. But anything outside 0 is small circle parallel of latitude. So distance SY can be obtained using this formula. The 2 points are on different sides of the prime meridian, and as such their angular difference is through addition. You have 140 degrees. The angle of latitude alpha is equal to 28.6 degrees. You come here and you replace all the parameters with what they stand for. You have it in this form. When you simplify, you have this to 1 decimal place. You have 13,667.4 kilometers. Example 21. The distance between two towns P, latitude theta degrees north, longitude 39 degrees west, and Q, latitude theta degrees north, longitude 21 degrees east, measured along their parallel of latitude is 3,520 kilometers. Calculate the value of theta to the nearest degree. Take pi equal to 22/7, radius of the earth equal to 6,400 kilometers along lines of latitude. That is small circle. Distance PQ is given by this formula, where distance PQ in the question is equal to 3,520 kilometers. From our usual notation, theta is the angle for longitude, but now you have it to be angle of latitude. There is no cause for alarm. Let alpha be equal to theta degrees sub 1, so that theta becomes angle of longitude, the way we have been using it. And let theta be the angle between the longitude. They are on different sides of the prime meridian. You have to add to get the angular difference, and that is 60 degrees. You come here and replace the various parameters with what they stand for. Remember, you want to get theta degrees sub 1 representing alpha, the angle of latitude. All right. If you simplify further, you have these results. To get cos theta degrees sub 1, multiply through by 2,520 to clear fraction and divide both sides by this coefficient. You have it in this form, and that is 0.525. To get theta, that is the angle of latitude, take the inverse of cosine of both sides in this form. Let's add bracket here, and when you evaluate this, you have this result. To the nearest degree, you have 58 degrees. End of lesson 7.